This is section 4.3, part B, trigonometric functions on the unit circle. A unit circle is a circle that has a radius of 1 centered at the origin. Since we use the formula to find theta is S over R, where S is the arc length and the radius of our circle is going to be 1, this means the measure of our arc length is exactly the same as the radian measure for a unit circle. So with our trigonometric functions, since we're letting the R value equal 1, we can simplify all of our functions that we had previously. So previously we said sine of theta was equal to y over r, but since r is 1, we can just write this as y. Cosine of theta was equal to x over r, but again, since r is equal to 1, we can just write that as x. Tangent will still remain y over x, and the other functions will still be the reciprocals. So a circular function is the trigonometric functions when defined as functions of the real number system using the unit circle. So here is the unit circle. This has the 16-point unit circle. These are the 16 most commonly found angles. They are written in degrees and they are written in radians. Now, if you notice a pattern, for all the ones that have a pi over 6, so if there's a 6 in the denominator, they are all going to be radical 3 over 2 and 1/2. You just are going to have to pay attention to what quadrant they are in. So anytime it's over 6, your two ordered pairs, or your ordered pair will be radical 3 over 2 and 1/2. If it's in the first quadrant, they're both positive. If it's in the second quadrant, the x's are negative, but the y's are positive. Third quadrant, they're both negative. In the fourth quadrant, the x's are negative, but the y's are positive. Sorry, the x's are positive and the y's are negative. If it ends, or if it's pi over 4, both values are going to be radical 2 over 2. But again, you are just going to have to determine what quadrant you are in to figure out what the values are, if they're positive or negative. And if your radian measure is over 3, your ordered pair will always be 1/2 and radical 3 over 2. You just have to determine if the values are positive or negative by what quadrant they are in. Now, to help you figure out your angles, because you are going to have to memorize these, the first one you add 30, add 15, add 15, add 30. Add 30, add 15, add 15, add 30. Add 30, add 15, add 15, add 30, and add 30, add 15, add 15, and then add 30 to get back to 360. On your radian measures, the first quadrant is going to be pi over 6, pi over 4, pi over 3, and then pi over 2. Now, pi over here can also be written as 2 pi over 2. And this can be written as 4 pi over 2. So this is 0 pi over 2, or we get 1 more than that, so 1 pi over 2, then 2 pi over 2, 3 pi over 2, and then 4 pi over 2. Those should be the easy ones. At pi over 6, we're at 1, or we can also write this as 3 pi over 3. We can write this as 4 pi over 4, and we can write this as 6 pi over 6. So if you're at 3 pi over 3, if we subtract to get back up here, that's going to get me 2 pi over 3, because 3 minus 1 is 2. 4 pi over 4, if I subtract 1, that gets me to 3 pi over 4. And 6 pi over 4, if I subtract 1, that gets me to 5 pi. Sorry, 6 pi over 6, subtract 1 gets me to 5 pi over 6. Now, once you go past pi, you are going to add instead of subtract. So since we're at 6 pi over 6, we go 1 more past it. That takes me to 7 pi over 6. 4 pi over 4, go 1 past it, is 5 pi over 6. And 3 pi over 3, go 1 more. That takes you to 4 pi over 3. Now we can write 4 pi over 2 also as 6 pi over 3 8 pi over 4 or 12 pi over 6. Again, we're going one less than that. So if we're at 12 pi over 6 and we go one less, that'll take me to 11 pi over 6. If I'm at 8 pi over 4 and I go one less, that's 7 pi over 4. And 6 pi over 3, one less than that, will be 5 pi over 3. So you will have to memorize your unit circle, try to find any tricks that work for you, but you will have a quiz over this before Christmas break. So we need to find the exact values from our unit circle, and if none actually exist, we will just write undefined. So if we need to find the sine of pi over 3, let's come back to our unit circle and let's erase all of those marks to make it a little bit easier to read. So if we are finding the sine of pi over 3 is right here. Now we need to remember that sine is just the y-coordinate. So the y-coordinate at pi over 3 is radical 3 over 2. So the sine of pi over 3 is just radical 3 over 2. The cosine of 135 degrees, cosine is the x-coordinate. So the x-coordinate for 135 degrees is negative radical 2 over 2. And the cosecant of 11 pi over 6. 11 pi over 6 is right here. Cosecant is just the reciprocal of sine, and sine is the y value. So the y value at 11 pi over 6 is negative 1/2. So since the sine of 11 pi over 6 is negative 1/2, to find the cosecant, we just find the reciprocal of that, or negative 2 over 1, which can just be simplified to be negative 2. Now, periodic functions are functions with the values that repeat at regular intervals. The values of sine and cosine lie in intervals from negative 1 to 1 and repeat for every integer multiple of 2 pi. The values of the tangent function repeat after a distance of pi on the number line. So a function of y is equal to f of t is periodic if there exists a positive real number c such that f of t plus c for all values of t is in the domain of the function. The smallest number c for which f is periodic is called the period of the function. So again, we're going to find the exact values of each of these expressions. Some of them may be on the unit circle, and some we may have to find before we can do anything else. So 11 pi over 4, if we look, is not on the unit circle. So we are going to have to figure out what would be a coterminal for 11 pi over 4. Now, to do this, we can subtract 2 pi. But to be able to subtract fractions, we are going to have the same denominator first. So 2 pi, or 2 pi over 1, we can multiply the numerator and the denominator by 4, and we can write 2 pi as 8 pi over 4. So 11 pi over 4 minus 8 pi over 4 will leave us with 3 pi over 4. Now, if we need to find the cosine of 3 pi over 4, remember cosine is the x value. So the x value at 3 pi over 4 is negative radical 2 over 2. To find the sine of negative 2 pi over 3, there are no negative values on the unit circle, but we can add 2 pi to it to see what the positive coterminal would be. Again, we need to make them have the same denominator. So 2 pi, if we want to have a denominator of 3, would be 6 pi over 3. Negative 2 pi plus 6 pi over 3 would give us 4 pi over 3. We need to find the sine of 4 pi over 3. So if we go back to our unit circle, remember sine is the y coordinate. So the y coordinate at 4 pi over 3 is negative radical 3 over 2. So if the sine of 4 pi over 3 is negative radical 3 over 2, then the sine of negative 2 pi over 3 would also be negative radical 3 over 2. Now we need to find the tangent of 19 pi over 6. Again, this is not on the unit circle, so we can subtract 2 pi, or in this case, since it's over 6, we can subtract 12 pi over 6, which will leave us with 7 pi over 6. Tangent is y over x. So if we take a look at 7 pi over 6, our y value is negative 1/2. Our x value is negative radical 3 over 2. So tangent is y over x. When you have a fraction over a fraction, remember you flip the second fraction and you multiply. The 2 on bottom and the 2 on top will cancel. The negatives will cancel because we have a negative for both of them. We multiply those together to become positive. So this is going to be 1 over radical 3. Since we can't leave a radical in the denominator, we're going to multiply the numerator and the denominator by radical 3. This is 1 times radical 3, or just radical 3, over 3. So the tangent of 19 pi over 6 will just be positive radical 3 over 3.